Hello there, folks. This is Ben Bracker.
And this is Varun Singh, and we are excited to share with you our vector display. So just a bit of background. Displays traditionally come in two types, which are rasterized and vectorized. So raster graphics are those like a bunch of pixels that you see on your screen, whereas vector graphics display images as these continuous lines and curves, which allows them to achieve very high resolution with very low memory. The only downside is that vector graphics can't fill the screen with color. So back in the day, a bunch of cool games were made for vector displays, including Asteroids and Space Fury. So you can see Asteroids black and white, Space Fury was in color. And nowadays, vector displays are used in a variety of different contexts as well, such as for this laser show on this cave wall in China, which is pretty cool.
Alrighty, now let's talk about how these work. So we borrowed a lot of the schematics from Asteroids, which is a digital vector generator. And so looking at the main pieces here, first player gives some input on their keyboard, and a Python script converts that into data over USB, and then the UART reads that in. Then the STM does the appropriate calculations, and it outputs vector data. First, the data go over SPI to these shift registers, which convert it to parallel. And then we have this linear interpolator. And so one way the linear interpolator can work is you can directly load a position. You can directly set the output numbers, and that's good for like initialization. But then if you want to be exciting, what if you actually want to draw a vector? Well, that uses these binary rate multipliers. And what they do is if you give them a certain number of input clock pulses, say 1024 to the 10, and if you give them an input, a binary number, it will output this number of pulses on the output clock. But the fun thing is it will spread those pulses out approximately evenly. But it will make sure that you get the exact number of pulses specified by this number. And so because it spreads the pulses out, you can end up, the end result is that you can increment each axis at different rates in time, And so that allows you to draw lines of different slopes. And because it has a precise guarantee about the number of output pulses, we know exactly where the beam will end up after it draws things out. So yeah, we have these spread out pulses, and then they're converted into, adding a number to the current position or subtracting a number to the current position. That conversion happens in this up-down counter. So if you have it in if this bit indicates the positive direction, the up counting, it'll just count up given these input pulses, and then if the sign is negative, it'll count down. That's pretty simple. And so then we have a raw interpolated signal after that. The only processing that happens after that is there's a undesirable condition you can imagine if the software accidentally draws off screen. What happens? Well, here we're in a 10-bit system, so if you go from 1023 to 1024, what will happen for the raw interpolated value is the 1024 will go to 0. And if you were to output that directly to the DAX in the monitor, that would ask the beam to move across the entire screen in a short amount of time, which would be undesirable. It would be bad for the monitor. And so then we have some muxes which look at instead of just a 10-bit number, they'll look at the 12-bit number, and they'll implement saturating arithmetic. So 1024 will get clipped off at 1023, and negative numbers will get clipped off at 0. So then that gives us our final good interpolated X and Y binary 10-bit numbers. Those go to some DACs, which get converted to the analog voltages. And that's basically it. The other piece is the color data, if you have a monitor that supports color. And there we just take some extra bits from the shift register and convert those to colors. There's also a latch to hold on to data, and then there's also a blanking input, because sometimes you want to draw a vector without actually outputting anything to the screen. So that allows you to reposition the beam without drawing anything. So you don't that way you can like not write in cursive all the time. You can have separate little letters and images. So that's how it works. Oh, this is my setup here. Yes. Here's I think 4 or 5 full breadboards, and here's the STM, the ADLM, and here's the vector monitor. It's a big old CRT. It has, I don't know, kilovolts of voltage somewhere in there. Be careful what you touch. And then this is an Atari PCB. You'll notice it's unplugged, and I have circuited into the wiring harness with some tape. I have the RGB inputs and the XY inputs and some ground signals too. So, and I'm also borrowing power from the power supply. So that's that.
Yep, just a little bit of hardware, not too much. I didn't think you could just crank out a 2-year-old in a night. So our project, the main result that we have is this interactive cube that our first deliverable was to have it operate in SCOBY. So here you can see sending WASD keys, and the cube is rotating and moving around exactly as desired.
That's pretty exciting.
Yeah, this was super exciting to reach.
You think it'd be like, I don't know, a few seconds of entertainment, but you can go on this for a few minutes.
Yeah,
we've done so.
Far more than advertised. Super cool. But the main highlight is that we got 2 cubes working on the display that Ben was talking about. And
that's multiplayer action.
Yeah, both can be controlled independently. They can be controlled over the internet, so I can send some keyboard commands and Ben can send some keyboard commands, and then we can watch both of them interact together. And so we will not do that now because that takes a while to set up. But what we will do is check out a demo of this working in action. So let me just go ahead and switch to that screen.
Let me pin my video. Okay, so now I'll open up the Python program, send keyboard input, and here we go. I can rotate this cube. I can rotate this cube. I can scale this cube. I can make it small. I can make it smaller. I can rotate it a bit. I think if I do this right, I can rotate it a bit, and then I can scale it back out. Oh no! Did I do that wrong?
Your scale. You rotate it the other way. Use J and L.
Oh, use J and L. Sorry. Oh. We figured out there is a fun feature.
It's rotating. Yeah. So what's happening is that the keep rotating. You keep using A.
Okay.
Yeah. So what's happening here? You can see that the cube on the left is kind of like orbiting around an axis. So as a feature and not a bug, definitely not a bug, is that the cubes themselves are rotating about axes that are where they originally started, but they're scaling in and out of the origin. So when we scale big or scale small, then what we can do is actually see it rotate about the axis and be offset, and that adds a lot of excitement and flavor to the game. And what Ben's showing right now is that if you scale them up too big or try to push them off screen, then the saturating boxes will take care of it and just clip it at the edge of the screen.
And that protects the monitor. You don't want to send too much voltage to them. But it's also a really cool effect. Like you can like squish in and then squish out.
Yep, it's melting from the side of the screen.
Oh yeah, like what? Tell me, what are there any games on the App Store that do this? I don't think so.
Yeah, definitely.
I don't think so. And look at this. I can even rotate it while it's squished in the side of the screen. Like, have you ever seen this kind of action before? I think not. Look at that. Oh yeah, look at that.
It's going across the screen. Yep. I believe entire movies could be made out of this. There literally is no better entertainment. I would know because I have hours of experience. I have hours of entertainment every day during lockdown.
So, like we should email like I think they're gonna make a Tron 3. We need to email these people, be like, hey, we got some visuals for you. I see a title screen in the making here.
You can't do any better than this. Like this is literally the pinnacle of human creation. We can call it the Michelangelo's David of art.
Who's David?
Exactly.
Oh,
It's
yeah.
all about cubes now. Also, by the way,
Night,
we did add
folks.
this text. Yeah, we did add this Hello Gamers stuff, just as a nice little touch.
Yeah.
Yeah. All right.
Night, folks.
Yep. Have fun.